the one we're going to test together is dissolved oxygen. So does anyone know anything about dissolved oxygen? Can you tell me anything? What does it mean?
I know it, like if it gets too low or too high, some fish die.
Okay, sure. So if you don't have enough, or you have too much, it can cause problems in the water. Not enough, and you'll have fish kills because they don't have enough oxygen to breathe. Too much, does anyone know what happens when you get too much oxygen in a lake? Dalton?
Never mind. I was gonna say in real life you get lightheaded.
Okay, so we can... Any other guesses?
Plants can't. Well, no. Yeah, plants can't grow.
Close. It's something that grows a lot. You end up with a lot of something that you don't necessarily want. Cody?
It's most like non-native water plants need a lot of oxygen.
Not necessarily.
Algae?
Algae, yeah. So you can get lots of algae, and then when you get lots of algae on top, that blocks the light from getting down to the rest of the lake, and that can cause problems for other animals or other plants that live in there and need light for photosynthesis and all kinds of other things. So you don't want too much dissolved oxygen, but at the same time you need to have some so that animals that need oxygen can get their oxygen and survive. So what we will test for is a basic dissolved oxygen test. What I need first is to borrow someone's water sample. Pour some of that in there and pour it all the way to the top. Very tippy top. Good. Perfect.
Very tippy top. Sure.
Now put that stopper in and just give it a little twisty turn around, make sure it's all mixed in there. And then the nice thing about these kits is they give you all kinds of fancy chemicals, and they put them in these little packets, so all you have to do is cut them open and dump them in, and they'll...
It has skulls on them, so I guess we're not supposed to eat it.
Yes, do not eat any of these. But they're pre-measured so that they'll go through a specific chemical reaction together, and then we can use that chemical reaction to determine how much oxygen is in our water. So these chemicals will react with each other and react with the oxygen in the water, and then we'll do another test later to tell exactly how much oxygen is dissolved in our water. So do you think that right now we'll have lots of oxygen or not much? What's your hypothesis? Yeah, what's your hypothesis? Not a lot. And what's your... Why do you think not a lot of oxygen? Does anybody agree? Not a lot? Raise your hand if you think not a lot of oxygen. Raise your hand if you think lots of oxygen. Raise your hand if you think somewhere in between. Raise your hand if you don't know. Okay. Why would you think not a lot? Alan? I'll give you a hint. You're right. Okay. Anybody else? Kate?
Because the ice is on top.
Exactly. Yeah, exactly. So it's like Brianna told us earlier. Right now we've got ice on top of our lake. So that's blocking off all the water from all the air and oxygen in the atmosphere above it. So normally, when there's not ice on the lake, it kind of cycles through, oxygen can dissolve down in, but when the water is covered up with ice, can oxygen get in the water? No. So we'd probably expect a pretty low reading for dissolved oxygen.
So in winter, a lot of fish die if there's not a lot of oxygen.
So in some cases, if the oxygen gets too low, you can end up with fish kills. So the fish are trapped under the ice, and they can live there. They kind of go into a state of, well, depending on the species, some go into a state of dormancy where they're just not active for the winter. But then if the oxygen gets too low, they can all die, and you end up with big fish kills where all the fish die. So as I put this second packet of chemicals in there, I'm going to stopper it again and mix it around, and you guys can make some observations of what you see happening in there. Raise your hand, give me some observations. Logan.
It has, it looks like bubbles and it turned a different color.
So it turned a different color and it has something that looks like bubbles a little bit. Blake?
It looks like a snow globe.
Like a snow globe. That's a very good description. description. Yeah.
It has like little particles of like chemicals in it.
Yeah, little particles of probably the chemicals or what those chemicals are reacting to produce. So they're going through a chemical reaction and they're going to make this weird powdery stuff that over time will settle out to the bottom, and that is called either precipitate or flocculant. And when it forms, it'll kind of float around for a while, and then because it's heavier than the water, settles out towards the bottom. So we will give it a chance to form and settle to the bottom after I mix it a few more times. And then it should eventually fill up to that little white line in the middle, and then we can move on. Until then, we have some other tests that we can do. We have a hardness test, we have a nitrate test, and we have pH. So I'm going to have, are you guys all one group over here?
These four.
Okay. So I'm going to have the group that's over here stick with me for now, and we'll do the hardness test. I'll have this group do the nitrate test, and I'll have that group